In this video, we'll be doing somewhat of a change of pace. We've covered almost all of the SQL statements that you'll need to know for this class. There'll be a little bit more on transactions and doing things with creating different types of tables and things like that a little bit later. But until we get to that, I want to talk about a particular data format that's especially common to have to deal with in databases. However, it isn't really standardized as much as we might like, and that is, how do you store representations of dates and times? All right, but before we get to that, I want to just do a quick multiple choice question to make sure that we're comfortable with qualified names. So for the given query seen below, how many columns should be returned from this select statement? So the correct answer here is 7. Now, why is it 7? Well, I say select star, which star gets expanded to mean all of the columns in the table students. Now, how many columns are there in the table students? There's 3: name, grade, enthusiasm. So the first column is name, then grade, then enthusiasm. Comma means, hey, there's more columns I need. Students.star. Now, students.star means the same thing as just star here. And so it would add name, grade, enthusiasm, comma, and then I say name, which is the name of one of the columns from students. So I have name, grade, enthusiasm, name, grade, enthusiasm, name. That's a total of 7 columns. This is especially important because in your projects, in your GitHub turn-in projects, you'll be needing to parse select statements that can have stars, qualified stars, as well as just using the columns of names from the table that you're given. So make sure that you're comfortable with the star operation, as well as how do you return multiple columns from a database. All right, so once again, select star is shorthand for just all of the columns there. It could also be qualified with the table name to make it unambiguous as to exactly what columns from which tables you care about. Okay, so now let's go to the main topic, that of representations of time. Okay, because it's really common to have to add entries to a database that represent a particular point in time. But unlike with a lot of other things, it's often unclear the amount of precision that we need at any point in time. For instance, sometimes we only care about dates, like it occurred on March 3rd, or a particular time, he woke up at 7 a.m. Sometimes we want different levels of precision. Like sometimes we want to say, actually, I want to know to the nearest millionth of a second when a particular event started or occurred. And it's even messier when you have to start thinking about time zones. I'll link to this video in the project description. Time zones make everything hellish. But we're not really going to worry about time zones for this class. We could have a whole class just on how to handle those appropriately. And the big problem with representing time is the fact that there are many competing standards. There's many different ways that you could represent dates that differ from place to place, from institution to institution. However, there is one standard that most enlightened people use, and that's called ISO 8601, the correct way to represent date times. I mean, it is what most people converge on as the best of many standards. So the way this works is, how do you represent a date in ISO 8601? Well, I've actually been using it in the schedule. It's 4 digits for the year, 2 digits for the month, 2 digits for the day. How do you represent time? You have hours, colon, minutes, colon, seconds, dot, and then fractional seconds. How do you represent a date time? A combination of a date and a time. You combine the two with a space. And why do you have it in this particular form? Well, if you notice, we always do the largest unit of time going to the smallest unit of time. Why is that nice? Because I can sort these dates times and date times, and I can get a chronological sort. If I sort, for instance, those date times, the dates that occurred first, the smallest dates, will be at the top of the list. And the other nice thing is that you can store this format just as a block of text. You don't have to have multiple different fields that represent the integer for hours, the integer for minutes, integer for seconds. It's just one text field. And if you need to do math with these dates, like figure out 1 day later and so forth, you can convert that text to some sort of internal programmatic representation of date times, do your math on it, and convert it back to text to store in the database. Storing a simple format in a database is a big boon for being able to use that database more effectively. Okay, so how do you work with times in SQLite? Well, so for instance, let's make up a table. Like say I'm trying to keep track of everybody's birthdays. Okay? So everybody has a name, everybody has a birthday. So if I want to say, hey, I'm going to stick my birthday in the database, I'd say insert into birthdays values, Josh, and my birthday represented in ISO 8601. And let's say I wanted to add Tom's birthday into the database as well. But hey, you know what? I want to specify a little bit more precision. I know the exact, tenth of a second the moment Tom was born. I can provide that information there. I could also say, oh, I have Dick's birthday as well, but I don't actually have his birth date. I just have the time of the day that he was born. And so if I say select star from birthdays, I can get all of that data that I stuck in because all of those dates are really just text. But the problem is that because some are dates, some are date times, some are just times, you can't compare them. By default, sorting these things won't make any sense. So the better way to work with dates is to use the date and time functions provided by SQLite. So for instance, you can input these things in the various forms, year, month, day, or hour, minute, second, and now the seconds is optional, or a date time object. So all of these represent different ways of representing time. You can also use the string now to represent the current time. And you can also do math with these timestamps by adding and removing time. So for instance, I could say 99 days, which represents a unit 99 days from now, or 2 hours in the past. We're not going to be going into too much detail with modifying timestamps, but if you want to, you can see the link here to look up how SQLite can handle doing arithmetic with date times. So the way that these date time functions work is they take text as an input, apply any modifiers on it, and return the resulting string. They return a ISO 8601 representation of the time. So if I say select date now, it'll return some date. Okay, today's date, which will be different whenever you run it. You can also say select time, and you give a particular unit of time. So I say, hey, I want to have 12:53, and then you can specify a duration that says, oh, I want 1 hour from that time, and it'll return 13:53:00 seconds. Okay. You can also say select a date time, and you can provide a date and a duration, and it will give you back a date time ISO 8601 representation. And so really, what do all these functions do? They take in strings that represent time and possibly a duration, and they return a ISO 8601 representation of the time as either date, time, or date time, depending on which function you use. Okay. Basically, impossible multiple choice question here. What should this return? Select the date, and I specify a time. So I would consider all of these to be reasonable, except for that third one. I think that third one is probably the one that doesn't make any sense. I could say, oh, you know what, I'm going to just pick an arbitrary date to return if you don't provide one. Like, for instance, January 1st of year 0, or the start of the epoch, January 1st of 1970, or even makes more sense to give an error because you're just like, you're selecting date and I have no way to infer the date. Another option might have been give today's date or something like that. The correct answer here is actually the evil one. For some reason, SQLite defaults to January 1st, 2000 if you don't specify a date in the string you provide. So if you start seeing January 1st, 2000 in your database, it probably means that you're doing something where you're selecting dates and not actually providing enough information. So the correct answer here is actually the third one. I don't understand why they chose that.